Hello everyone. Today I want to talk about multi-head attention. So to do a quick recap, we talk about attention mechanism, and we know it can capture context and relationship between tokens. However, natural language is a very complex problem and usually have multiple aspects of context and relationship. For example, in this sentence, date is my favorite fruit. We know date is a fruit, and we know date is my favorite fruit, and we know the concept of favorites applies to a date. And there are a lot more actually. For example, we know this language, this sentence probably has a neutral mood, or even like a neutral to positive mood, because we're talking about our favorite stuff. So there are a lot of like complex and multiple layers of context and relationship in just one simple sentence. And are we only going to use one type of attention to capture it? The answer is no. We usually use different set of parameters to capture different type of context and relationship. And sometimes we don't even know what is the type of relationship. We just use a different set of parameters. This is a example for natural language. Next, I'm gonna also show an example for computer vision. So Transformer is a very powerful tool. Don't get me wrong, it's not only useful for natural language, we also use it for computer vision. And this is one example of different attention mechanisms intuition. We have a image with a full background, and there's three filters. There's three attention mechanisms. First one, attention filter one, just figure out who's the person. This is Hua Mulan. And then the second attention focus on figuring out what is the sky. And the third one focus on figuring out what is the mountains. So this is another example of intuition of attention mechanism and why we need multiple different types of them. Okay, so this was the previous attention block that I went through. So we already know with the input word embedding plus position embedding, we go through linear layers. And then for key and queries, after we go through linear layers, we go through matrix multiplication, and then we go through softmax, scale, ignore mask. I'm going to talk about it in the next section. And then we also do another matrix multiplication with values and get the attention scores. So the question is, how do we introduce the multi-headness of attention to this problem? So this is multi-head attention block. We basically have the same input. The input dimension doesn't change. But when it goes through the different blocks, now we go through multiple head. Let's say for the first one, we call it head 1, and for the last one, we call it head H. So H is the number of heads we are going to go through, and each of them focus on capturing one specific relationship. So it still go through the linear layers and still keys, queries, values, still go through the matrix multiplication, still go through normalization and matrix multiplication with values. But now, since there are H heads, now we have H Y vectors, right? And each Y vector is with the same dimension of V. But then we also said before, we want the output dimension to be the same as the input dimension. So we can like layer hundreds of attention block. But this way the output dimension is H times of input. So how do we solve this? We solve it by first concatenate all of the result. So we append one after one. And we get a n multiplied by h dimensions of y vectors. And then we go through the linear layer again, and this time the linear layer's focus is just to remap the dimension back to n, and we get another y to yn. This is a typo actually. This y1 is actually different from the y1 here. So it's a different vectors. The dimension is the same with b, but it's from multi-head. So how do we achieve this? Right? How can we use linear layer to drop the dimension from n multiplied by h to n? So we're gonna before I show that, I just want to say previously we went through the scaled dot product attention. We went through the linear layer here. This time we were focusing on the concat and linear layer here. So the way linear layer works is like this. So linear layer, I've heard like all other names people call it. I've heard dense layers, I've heard fully connected layer. So they're all pointing to the same like concept. So let's say y is the input and b is the output of the layers. Then we actually have a lot of like have all of them fully connected. And this is just a view of it. In between there could be like multiple layers of fully connected layer. And in this way, we are able to map the input to output, and we can also change the input dimension to the output dimension that we want. In this case, the example is we change a 5 by 1 dimension to 3 by 1 dimension. So this is how linear or dense or fully connected layer drop the concatenated dimensions back to the original dimension that we want. So next time I'm gonna talk about this mask and a very important topic, which is key value cache. Thank you everyone, hope this is helpful.